Hello, everybody. I hope you're doing well today. My name is Dr. Zach Hilgendorf. I'm a faculty in the Department of Geography and Anthropology at the University of Wisconsin, Eau Claire, and I'm here to talk to you today about why are there dunes at the Town of Union Conservancy. And before I do so, I just want to make sure I thank Sarah Norman for inviting me to talk to you all and nerd out and talk about something I'm passionate about and I'm super interested in. I wish I was there in person. Unfortunately, I'm up in Duluth, Minnesota right now. Not a terrible place to be, but I have some project meetings going on for some other stuff, so I am away. But hopefully this will be a good stand-in to teach you all about the cool things at Town of Union. Now, a little bit of an outline. We're first going to talk about glaciers, and then we're going to talk about rivers, and then we're going to talk about climate. And you might be saying to yourself, none of those are dunes. The dunes will come later, but we got to set the story up first because this is a really cool and complex story that takes in tens of thousands of years of history to give you the cool features that you get to see out there. Now, pay attention to the slide titles. I tried to name them fun things. Ice Ice Baby. Let's talk about glaciers. Now, more specifically, let's talk about an ice sheet. Now, an ice sheet is this massive continental scale thing. And we see it here. We see a few different ice sheets. We see the Laurentide ice sheet, which is the big light blue, the Cordilleran ice sheet, which is the darker blue, and the Greenland ice sheet. The one that's most pertinent to our story is the Laurentide ice sheet, which centered over Hudson Bay in northern Canada. Now, the Laurentide ice sheet, think of it as this thousands of feet thick mass of ice moving, radiating out from Hudson Bay, so flowing in all directions away from Hudson Bay. Now you see that we have extents of the Laurentide ice sheet down here in the upper Midwest, and that's the next really important part of our story. So let's zoom in a little bit. Here we have what Wisconsin would have looked like about 22,000 years ago, based off some data by kind of aggregated by Mickelson and Addig a couple of years back. And you're looking at the Chippewa lobe of the Laurentide ice sheet right here, named because we found its evidence in the Chippewa Moraine in Chippewa County. Now, if you go up there, the Ice Age Interpretive Center is a really awesome place to go learn more about how glaciers affected this part of the state. But for now, let's just go ahead and think about what glaciers do. Now, glaciers act as massive bulldozers that kind of take the landscape and scrape it flat. As they do so, they're picking up all this different type of boulders, sometimes house-sized boulders or bigger, gravels, sands, everything in their path, grinding it into little tiny bits of powder. Now, as they do so, all that sediment is moving somewhere, usually up into the glacier and towards the edge of it. Now, as it does that, and the glacier starts to push that sediment somewhere and then recede, what's left is what we call a moraine. Now, a moraine is just this mix of all this random stuff, boulders, gravels, cobbles, sand, silts, and clays, everything. Now, what's coming out of that is this massive amount of sediment. That sediment is also being reworked by all the meltwater coming off of that glacier. Then, as the glacier starts to recede, we had ice out, so ice was out of the Chippewa River Basin sometime around 18,500 years ago. We started to have the ancestral Chippewa River, the glacial Chippewa River, start to rework all of that sediment. Now, here is the next cool part of our story, and we're kind of transitioning into thinking about rivers. So as those glacial or the ice sheet was melting, that water was pooling in some places on the surface of that ice sheet. One place in particular we call Glacial Lake Agassiz, kind of in that hashed line that you see there. There, it was a southern outlet to Glacial Lake Agassiz that was dammed by ice. So basically what's happening is you've got all this water pooling on the surface. When that ice dam fails, it fails catastrophically, barreling down the Little Minnesota River, the ancestral Minnesota, into the Mississippi River and down out of the upper Mississippi River watershed, going right past the Chippewa River. Now, as it does that, it cuts down into the landscape because all that sediment's being moved out. And as it's cutting down, that all the rivers that are flowing into the Mississippi have to start adjusting and adjusting to that new level that they all flow into, which is where we transition to rivers. Sorry, my cat wanted to say hi. Old Black Waters, keep on rolling. Mississippi Moon, which keep on shining. Now, here we are draining the glacial margin in the ancestral Chippewa River. This is a really important point to our story. So the Red Cedar and the Chippewa River were both glacial meltwater streams. They're taking sediment and water away from the glaciers and reworking it, moving it across the landscape. The ancestral Chippewa would have looked something like this. Fascinating. These are both from New Zealand. So without the mountains, the Chippewa River would have looked something like this, what we call a braided stream channel, moving massive amounts of sediment downstream, a grading, so the level of the river and the level of the surface is rising because the river can't work through all of that sediment and move it out of the watershed, so it's reworking it, moving back and forth, depositing in different places on the surface. Now you might look and say there's no way anything in the Chippewa River used to look like that, to which I will say, hold tight. Here we're looking at a historic aerial image of the Chippewa River just downstream from Town of Union Conservancy, just a couple miles. And you see all those squiggles in the farm fields? That's exactly what you're looking at. These are old, preserved, braided channels that are now farm fields across the upper portion of the basin. So this was the top level that the Chippewa River got to as it was a grading. And these are preserved in the surface. Tons of really cool features you can see all over this map. We're just going to focus on that concept, this massive pulse of sediment moving its way through. Now that top level, if we move down here, a little bit downstream from where you guys are right now, my home, right, University of Wisconsin, Eau Claire, we have this feature up here, the Wissota Terrace. Now, the Wissota Terrace is the top level that the Chippewa River graded to when it was moving through all that sediment. Now, here in Eau Claire, anywhere from about 115 or so feet above the modern Chippewa River. In some places, it's higher, as we'll see. So as that river grades, it starts to respond to incision events, or it starts to respond when that sediment is worked through, and it starts to incise. And as it does so, it leads to all of these different little features that you see in this picture kind of surrounding me right now, things we call terraces. Now, terraces are old floodplains of the river preserved from thousands of years ago, in our case. So you can see here, this top X is the Wissota Terrace. Then we step down and we step down. And you notice the stair-stepping pattern with these colors as we get lower and lower onto the floodplain, or the modern floodplain of the river, which is that last X that I drew. Now, as the river is moving back and forth, it's migrating through its floodplain, it's reworking things, it's cutting into those banks and those bluffs. Now, that is a really important thing to remember as we kind of come back to our story here in just a couple of slides. Then we have to factor in the climate of the time. Now, the climate back then was vastly different than the climate we experience today. During glacial times, this part of the world would have basically been a tundra. It would have been so cold that only stunted vegetation would have likely been living here. And it would look something like this. This is from near the Arctic Circle is where this picture would have come from. So all of these little tiny shrubs and lichens and herbs and things like that, that's what it would have looked like probably in your own backyard. But then, as that glacier starts to move away, we start transitioning vegetation assemblages towards warmer and warmer types of vegetation. So where we would have started at tundra, we see here, maybe then we transition into boreal forest, then we transition into maybe mixed forest, and perhaps hardwood forests and grasslands, depending on how much moisture you have available. And that's the really important part here, because this puts us on a precipice. If we start to dry out, that vegetation goes away. If the vegetation goes away, there's nothing holding the sediment down on the surface. And that's really important for dunes. Now, then we had certain things like the medieval warm period, which is a period of time where we had an increase in temperatures kind of across the world. And we're not really going to focus on why, the reasons for that. And in fact, the medieval warm period, although it was warmer relative to the time, is dwarfed by the temperatures that we're experiencing today, which is a really interesting concept, thinking about whether or not dunes could remobilize on the surface, but that's a talk for another day. But here we can see that we had this warm period centered around 12,000 or 1,200 years in the Common Era. So, 820 years ago or so. And then we had some other little warm influxes, and we had our little ice age. So all of these are different periods of warming or random temperature changes. Not random, there's reason for it, but again, too much. We're not going to get into that today. So to get dunes, we need a few different things. We need sediment supply. The Chippewa River is reworking all this glacial outwash. So boom, we've got sediment supply. We need competent winds, so winds that can move sediment around. And based off a lot of work by a gentleman named Randy Schetzel out of Michigan State, and some of my colleagues, we're pretty confident that, yes, we absolutely had competent winds. You'll see the proof in the pudding here in just a little bit. We need a nearby source. Remember all those bluffs and banks that are getting eroded into? That's a pretty good nearby source. Check. And then you need an appropriate amount of vegetation, meaning lack thereof. So as temperatures are shifting and changing, patterns in precipitation are changing, we're seeing decreases in the amount of vegetation spread across the surface. Check. All right. We've got everything we need. How do we get dunes at the Town of Union Conservancy? Well, at Town of Union, we have what we call clifftop dunes. These are, as they're named, dunes that form on the edge of a cliff. Now, the sediment is coming from below. It's coming from those eroded banks. It's being deposited at the top of the cliff. It's not coming from inland or away from the river and moving towards the river. It's starting at the edge of the river and moving inland. So how does that actually work? Well, we've talked about the story so far, and this is a diagram that I've adapted from a colleague of mine, Jason Millette, who's a master's student who graduated in 2019 at Minnesota State, working with a number of my colleagues currently. So here we've got the Chippewa River aggrading, so rising up, depositing all of the sediment, reworking through everything. Then you have some type of incision event. The river drops its level, cuts into the landscape, starts meandering back and forth, cutting into those banks and bluffs, exposing lots and lots of fresh sediment for the wind to do fun things with. Then we have a climate shift. So something happens where you've got this change in temperature, decreasing precipitation, and a response mainly through a decrease in vegetation and a decrease in soil moisture, freeing up that sediment to be reworked by the wind. The river erosion is exposing more and more sediment, making it available for the wind to move around. If winds are competent, they can move that sediment around, and they're getting pushed up based on dominant regional wind patterns. We can assume we've got these winds that are flowing up and being pushed up the slope. Now, I'm not going to get into fluid dynamics. That's a story that will bore you to tears and is for, I'd say another day, but don't even worry about that. But what happens when wind is moving up and over a slope? It compresses. And as it compresses, it speeds up. And as it speeds up, it's moving that sediment uphill. But once it hits the crest, once it hits the top of that hill, those what we call flow lines expand. And as they expand, they lose that competency and they drop the sediment out. And that's exactly what you're seeing right here. So as that wind is slowing, once it hits the top of that erosional surface, it slows down and it dumps that sediment right out at the edge. It might have been a grain that was right here, and then it was just deposited right here. And as it keeps, that wind is keeps blowing across the surface, it's pushing that sand inland, a dune, and it's depositing more and more sand from that cut bank. Now, to finish off that story, we have climate shift that allows vegetation to start moving back in. Perhaps we start to see a parabolic dune, so vegetation is colonizing the outward edges, the arms of the dune, but fresh sediment is still being deposited on the inland side of the dune and still moving it in until it starts to fully hair over, those dunes fully stabilize, and we see the dunes that we have very evident at Town of Union Conservancy. All over the place. Notice these nice big arcuate shapes here and over here, all over the place. Now this one here that I'm marking right now, that is the tallest dune that I could find in the area. That's about 157 feet above the modern Chippewa River. Pretty cool features, right? Now you might be saying to yourself, wow, this is awesome. Where else are you going to find something like this? And not to say that Town of Union Conservancy doesn't have awesome dunes, because it does. But when you start to zoom out and you start to look for these things in the landform or in the Chippewa River, they're everywhere. And we see them all over the place. All of those yellow dots are different clifftop dunes. Those are the three that we just looked at. Now, if you zoom out even more and you start to look at just different aeolian features, we have a vast history of aeolian or wind-blown activity here in the region, depositing different types of dunes, reworking sand across the surface, and leading to a really dynamic and fascinating story that helps us better understand how this part of the world has evolved over the last 15,000 years or so. So dunes are common features in the upper Midwest. They just look a little bit different than the ones that you would see in other parts of the world, like the Sahara, the Sahel, the Australian outback, all over the place, right? They look a little bit different than that. So I hope you enjoyed that little foray into my world of what we call geomorphology. Please feel free to reach out with any questions, Sarah. You can feel free to pass along my email. I provided it here. This will be posted to YouTube, so if you ever want to go back and rewatch it, you can feel free. Thank you very much for your time today, and I hope you have a wonderful day. Thank you.